Hi, and welcome to this introduction video for the Pale Blue ROV simulator. My name is Snorre Balkøy. I am currently the discipline lead for ROV in Aker Solutions, and I've been working together with Pale Blue with the development of this software. This collaboration with Pale Blue came as a result of our needs to simulate scenes with a lot of polygons, as we're looking at everything from a global perspective. When we're doing our ROV access verifications, we kind of need to have everything in the scene at the same time, and the simulator software we were using at the time just could not handle the amount of data, so the performance was really poor, and that's what we were trying to fix and accommodate with this new development. So in this video I'll go through some of the functionality in Pale Blue software and how it's used for access verification, and we'll touch up a bit on the Unity user interface. The Pale Blue ROV simulator is developed as an add-on or a plugin for Unity. And the reason for this is the Unity editor already have so much of the functionality that we need. So there's a much shorter way to develop the software rather than starting from scratch. Another thing is that Unity is under constant development and new functionality is added, and the opportunities is enormous, almost limitless. For those who don't know Unity, it's basically a gaming platform that's also used for movie making, so we have that. And building the ROV simulator on top of Unity means a lot shorter development times, and also it's very cost efficient. You will need, in addition, somewhere how to import your CAD models into Unity. There are several ways of doing that. It has a built-in FBX importer, but if you want to go directly from other CAD formats, I would suggest using PixYZ, as it's very straightforward and you can do optimization on import to save time. Okay, so let's get into it. In this video I'm not going to go into Unity as such. There are plenty of other videos out there that you can look at to learn how to use Unity. But we're going to go with the Pale Blue installation and functionality, and then see how we use it. As for installing Pale Blue into Unity, you will first go to Assets, Import Package, Custom Package, and then select the plugin from Pale Blue and open. I've already installed it, so I don't need to do that, but after the import you will get a screen. It comes up with all the files to import, and then you just select import at the bottom. It's going to take a while, but be patient and wait for the prompt to restart the project. When it restarts, you are ready to go. So with the plugin installed, you should now add ROV to the scene. We do that in the project tab under Assets, Pale Blue Scenes, and we just double click Startup. Now the scene is set up, and if I now hit play. We'll be able to fly around the ROV. And how the ROV is set up, you just turn the frames off. It's got a couple of pan tilt units, and you have a couple of manipulators. And of course, if you for some reason wanted to have a different manipulator on, for instance the Atlas grabber arm, you can easily change that. There are a few variations of manipulators in the software, and others could be added. Same goes for ROV models. You can just obtain the 3D model of any ROV and put it in. Also, the ROV has a TMS that can be connected, and when you hit play, you can see them all attached and working together. As standard, this tether is set up for automatic. This can be changed in the toolbar. We have the tether controls, where you can change to manual operations, and you can set tether length, and you can do a manual in and out. Another neat functionality for ROV access verification is the addition of the envelope box. This is a requirement to have a set amount of envelope around the ROV to ensure proper access. So by using this box in combination with collisions on structures we are verifying, I will show this later. The envelope box is set up as a standard 0.5 meters in a direction, but this can be changed as you like. We've also set up a color spectrum so that we have a yellow color for a slight penetration, and then red for a full breach. In the pale blue toolbar, you also have the option of adding current. So if I add current in the water, you will see that it's pushing the ROV sideways, and I would have to use force to counteract it. The second I let the joystick go, it starts drifting with the current. In the toolbar, we also have some measurement functions that we can use, and I'll show these later. Up top here, you have the pale blue menu, and here we have the possibility of import with a certain rule set. We have the hierarchy assistant and keyframes. And keyframes is something I'll get into more later. And we also have the option to open the viewports. This will come on during play mode. Just in case you want to change the layout for the cameras, you have 3 preset layouts made up. You can also maximize this to have a bigger screen, or pull it over to a second screen if you want to have access to the editor window while having the viewports visible. Also, if you need additional cameras, these can be added and made selectable in the viewport. So, okay, let's get some CAD models into the scene. I believe I have some pre-made. For when you don't have pre-made CAD models, you want to import them from what you got from your designers or from your sub database or something like that, you would use the pale blue import models, and you would select the CAD file and you would open it. Easy as that, right? Then we have to place the structure, and as you can see, this is not positioned correctly, and that's because these CAD models don't originate from the same assembly, so they don't have the same 0 point. And the best way to align them is to use the measurement tool on the pale blue toolbar and then just select a couple of points, get the measurements, and then you can just use the numbers and align it. Now you see it should be good. I found that function to be really helpful. And then we can just reset the ruler, and then we see that we want to place this in the opposite direction, so we just go into the rotation and do it -90 instead, and we are aligned and good to go. The first thing I want to check is there enough space for the ROV to get into this ROV panel and do its operations. And the easiest way to do that is to add collisions to whatever is relevant on the structure. Create a collider. Execute. So that means that we now have added colliders, and the way to see that is if you go turn it green, we select the topo we just made, you can see that all the surfaces that turn into a collider is now green. And that means that when we fly the ROV in and we turn on the with the envelope turn on, we will be able to see when we breach the envelope. A little breach means yellow, a larger breach means red color. It's very visual and easy to see. Next is a short animation to show ROV access for replacing a chemical injection throttle valve. You can see it, the envelope stays green. We have good stabilization, and we have the necessary access to perform the task. Stabilization is also crucial to verify that we have the proper means of stabilizing the ROV for each of the ROV tasks that are going to be performed. And there are really 3 types: docking, roof platform, or grab bars. All have their own use areas. Grab bars being the most practical because of its flexibility, and it takes up less space. roof is the best when it comes to stabilization because you are very stable. And you would be with docking as well, but it's very limited the operations you can do because of the locked arm angle. You have no way of rotating your ROV to get in a better position. Here you can see how we rotate the ROV to gain access to that valve. And because we have the ability to rotate the ROV, we now have more flexibility to reach a bigger portion of this panel than we would have if there was a docking interface on the bottom. One of the important requirements for grab bars is that we have enough space around them so we don't hit critical items with the manipulator as we grab on. During the design phase, we receive models from the designers. We do access verification for all the ROV tasks that's to be performed. Each of the tasks we record a keyframe. And the reason for this is that in the design phase we can get many iterations of the same model with small or larger changes, and setting up the ROV, getting the arms into place, it takes time. So to save time, we can create keyframes for all the tasks. And then when we have to come back and recheck it, so if I now move the ROV away, let's see, let's move this away. Got a new model in, I want to recheck the valve interface. I can just activate the keyframe and ROV sets up in the same position. And this is a huge time saver, because compared to me setting the ROV up and doing this manually, for each task, it's better when you've done it once and you don't have to do it again. And also when we do this, we identify all the possible issues with the current design. So like in this situation, we have all the EFLs hanging down in the area where we need to have position the arm to get onto that valve, right? Other issues might be, for instance, here we have a lot of EFLs on the side of the grab bar, and we're coming in to grab on. You might get close. and has a potential risk of damaging the electrical connectors. Then we have to verify all the marking, that it's first of all readable, preferably according to API standards with regards to size. And then another thing that's important to check are all the indicators. And these indicators need to be checked with the tool in place, right? I'm not sure you can see that in here. But that indicator is really difficult to see because the cutout is too small. So when we place the tool and we have just a glimpse of the indicator showing. So with this software, I could easily have put physics on pretty much everything in the scene. But that comes at a cost. It really hits performance, and performance slows down my work. I don't have time to wait or to waste. Another thing is other simulators, they also have large models in their simulations. Yes, they do, but they've usually been prepared up front, so the models have been optimized. A lot of the small details were removed just to get that performance. And when you're doing ROV access verification, the devil's in the details, so it's important to have the details in the scene, not remove them because of performance. And then there's the fact that during the design phase, and the designers ask me to verify what they've done so far, I do a check, send it back with comments. They make changes, they send me a new version of the CAD, I recheck it again. If I'm going to spend too much time building physics on each iteration, I'm going to spend a lot of time doing that and not doing ROV access checks. And then again, it's the other thing you have to consider is that this is like fresh goods. If I sit on a model for a week or two to put in physics or make pretty, then the designers have to sit and wait. They can't move on. And that will have an impact on our deliveries. So we can't do that. We have to be able to do rapid iterations and give quick responses to our designers. So basically the limitation is not in the software, it's in time management. And as for time management, the use of keyframes has had a really good impact on time spent. And also the fact that we can now kind of pre-check all our standard components. So if a Christmas tree is used in one structure this month and in a different structure next month, I pretty much have all the access checks ready, and I can just click through it to verify it will fit in a new structure. And that is very time saving. So I'm really happy about the functionality with the keyframes. And they can also be used to make animations, and some of the animations shown in this video was made with the keyframes. Another great feature with the keyframes is the ability to use them for creating animations. And yeah, let's create one right now, where we open up this lock and fly to the side and monitor the opening of the hatch. So basically I need to do some more keyframes. I'm going to move to the last keyframe I have. So I'm going to get this arm together and then move the ROV up. Do one keyframe, like 9. Then I'm going to move a bit further back. Like this, and also lift the camera view. Create a new keyframe. And then the last one we just move the camera over to the final open position. Maybe a tad more backwards as well. Okay, so final keyframe. $11. Okay. So what we do is that we go to timelines. I have already established a timeline for this. I'm just gonna turn off play on wake, because that is always a problem. And then we're gonna start adding keyframes. First off, we're going to put in the ROV as the constructor, and then we're going to add keyframes. And I think that we were going to start from 4. And then we go on, keyframe, and we do 5. Wrong 5. Sorry, that's a bit quick. Roof 5. Then we have to connect the dots. Keyframe 6. Again, then add keyframe 7. So this is a bit tedious. I'm sure we can come up with a better way of doing this. Maybe being able to do a selection instead. So, how far have we come? 10. And last one, that should be a probably this one. I don't think I managed to name that correctly. That's fine. So this should go to new keyframe, and then we have to move back and add the end keyframe for these. That should be 7, yeah, that's good. Okay. So now we have all the keyframes. Let's see now how it is. That's good. So, next we need to do is to find that lock. So that is the lock. Okay. So then we're going back into the timeline, and we are going to create a animation track, and we're going to put this in. Recording. So we set this starting position as recorded position. And then we move it to about here. And for this we rotate it to an upwards position. And then we go to the next one, and here we slide it over. Here, and then in the last one we rotate it back to the starting position. See, that was not all great, so let's just go back here. Then we're going to fix this one. I'm going to rotate it all the way up. I'm going to put it a little bit further in. I think that should fix it. It's now moving pretty much as it should, and we're moving away. So the next step is to, from this point on, rotate the hatch. That means we need to add another animation track, and we should bring the hatch into that. And then we need to do some recording there as well, and of course I have to do that in off mode. So let's just put this back in here, and then do a record. This is the rotation to 0.001. here approximately. We should put it at 60. Then we move to the end. And we put in a full 110, which I believe is the full opening. Okay. So we stop the recording and we move this back. And we add a recorder track for this. And we add a recorder clip. To start here and move all the way up to here, and we let that record in game view, and we set the output range to 4K, and we call this hatch open. Just so I can find it later. Go back. We are going to mute. I just wanted to see how this all turned out before we So, looks good. So let's unmute this, and let's just the camera angle looks good, and it's not, oh yeah, it's changing. That's fine. Okay, so then we do a play. This is going to move half speed or something because it's recording with twice the resolution of the screen. And that was that. Now you're going to see the final result. Just one thing before we play the clip. I didn't adjust any of the time settings for the keyframes, so some parts might move faster than it should and some might move slower. But it's basically just a matter of extending or shortening each of the time frames to adjust the length of each clip. Looks alright. I must admit that I'm still just a newbie when it comes to animations in the software. So I still have a lot to learn, and there's a lot of functionality that I'm not familiar with yet, unfortunately. But still, it's easy, and the result turns out pretty good. So I hope this presentation has given you some understanding on how the software is being used and how to use it. little glimmer of the possibilities that lies within this software. Thanks for now.